So we're starting chapter 13, statistics. This little video will look at the mean and median. So this example one has 6 test scores. So whenever you have a list of data, the sample size or number of elements in your data, you just count them. So I got 6 things. The mean you've been finding your whole life. It's the same as finding an average, where you add everything up and then divide by how many things you have. The only problem is we don't use that word anymore in statistics. So the mean, we give it the symbol X bar. Here's another symbol, capital sigma. This says add everything up. And what are we adding up? We're adding up those 6 scores, then we're dividing by the 6. So if we add up all of these x's, these are your x's, all of these 6 of these things, we get 495. So my mean would be 495 divided by 6. That's 82.5. So that's the mean test score of these 6 scores. Ugly ass 5. Okay, I'm going to play with it just a bit. I'm going to extend this example. I'm going to add one more score. I'm going to add a score of 18. Now let's see what this does to the mean. So again, I'm going to add up all the scores. Now I'm going to divide by 7 because once we added the 18, our sample size went up by 1. This now gives me 513 divided by 7. My new mean is 73.3. So, before the 18 in the previous problem, our mean was 82.5. So look what the low score did. It dropped the mean quite a bit. So that 18, we would call it an outlier, and it affected the mean dramatically. Okay, now I'm going to the next example because I'm going to do the median. But I'm going to use this data. Let's leave our 18 out for now. So first, to do the median, we have to put the data in order. So for the median, you have to order the data. And I'll show you a graph or a plot how to do that later that makes it much easier to do. But with this many, there's only 6 of them, we can order it 65. Okay, so now I've got all my data in order. And what the median does is it just takes all your data. Think of it as a big candy bar. The median cuts it in half. So you would have 50% above the median and 50% of your data below. So if we have these 6 scores, my median is right in between 84 and 88. You can probably see it's 86 without doing the math. If you add 2 things, divide by 2, you get the number right in between. So my median is 86. So for this data, remember our mean was 82.5. Median is 86. They're very close together. We'll talk about what they do in a bit, because now I'm going to go back and I'm going to add my outlier that 18 and do the median again. Get rid of that. So now I've got an 18 here. Remember, my mean for this was 73.3. That 18 dropped the mean. But now I've got n equals 7. And when your number of data points is odd, your median will be a data point. Look at 84. I've got 3 below, 3 above, that's right in the middle. So the median is 84. So the outlier really affected the mean, but not the median so much. That's why sometimes we use the median if we're worried about outliers. So I'm going to show that one more time. Let's see, 84 in the middle. Sometimes you have to be drastic. Suppose a new data point was 1,000. Well, my median doesn't move much. My median is now 88. It only moved from 84 to 88. But look at the X-bar. Add all of these up. I'll let you do it. Divide by 7. You get 213.6. So just to finish this video, I'll give you an idea of what the median and mean are finding. They're both measures of central tendency, which is the big topic in this section. We kind of want to know where the middle of the data is. So if you can think of the mean as think of finding a balancing point. So my balancing point right now would be right in the middle. Everything's perfectly balanced. So this is looking at X bar. If you look at the median, there's my data, it doesn't matter about how it's balanced, it just cuts it in half. So here they're roughly the same. But if you think of a teeter-totter, right? If now suddenly you've got my little brother weighs 250 pounds there, what does it do to the mean? Well, that balancing point, if I'm on the other side here, it moves it closer to him, but the median doesn't change because it just cuts it in half. It's not affected by the outlier.